Hey, this is Jonathan, and I'm just going to be continuing where I last left off, putting together the progression filler with the fast filler. So I think what we want to do here is, instead of doing this print line, we're going to actually try and return all of the locations once they're all filled. So we're going to have a bunch of filled locations as our final result. So let's do that real quick. Oh yeah, I decided to bump up the font size a bit. Size 18 right now instead of, what was it, 15? Seems a little bit more readable on the video. I mean, before it was still readable, but I decided that this combined with the upgrade, I guess, to 1080p makes it a bit more readable without having to squint or anything. So yeah, that's what I've kind of decided to do. And for now we're going to return an empty vector because we don't really know what the final result's going to look like. I guess it didn't really matter if I had changed the signature or not right now, but whatever. Let's just try and... Oops, that's what I wanted to do. Let's try and get both of these fillers working here. Alright, so the fast filler. Before we do anything, I think what we want to do is an assert. So I want to do like a debug assert, I guess, and make sure that... what are we looking for? We want to make sure that items.length is the same as locations.length because we're going to be zipping them together. So with that should do it. That should be good enough. So, oh yes, and I have this to fill in. Right, so first filled locations maybe? I don't know. Yeah, let's do that equals first filled locations, I guess. And I want to use the fast filler here. I forgot what it takes. Items and locations, and they're both vectors. Okay. So we need what? The remaining locations? I think we are getting the remaining locations, right? Yeah, we have this progression filler result. And that would do it. I guess I should leave a comment and say I guess we could say contains filled item, or I guess filled locations and what? Remaining empty locations? Yeah, okay. I think that's a pretty good comment to leave there. Let's see. Alright, so we're gonna have to... Actually, you know what? I can do better than that. Filled, and let's say, I don't know, remaining blocks. Filled blocks, remaining blocks. How's that? I like that. I think that's fine. I'll be able to understand that. Now, maybe I'll put this on another line because it's getting kind of long. Yeah, there we go. Then I'm gonna give it... Okay, so I need ownership. Yes, I do. I need ownership. So if I want to own these, I just pass them in. Right, I gave them names too. So remaining blocks. That should be this list of locations, and then there's items. So obviously items is going to be whatever items are remaining, so any non-progression items. So thankfully we have this other items, and I do own other items, if I'm not mistaken. Yeah, I should be able to just do that because I own that value. So we do the fast filler. The fast filler is going to return a vector of filled locations, and because it's returning a vector, we don't really need anything else. We can just return. So yeah, there we go. That should, in theory, do it. Now I'm not really sure how all the ownership rules are going to work out here, but I'm at least somewhat confident that this is all I need. Why do I have... Oh, wait, we're not done. We're not done. The reason why is because filled locations, it hasn't been appended to the result of fast filler. Right, so we need to look up how to append these two lists together. So to do that, so thankfully I'm already on the vector page, that's awesome. We'll just, is it extend? Not really sure, maybe there's an append? Nope. Well, there's this. Leaving the other one empty, okay. Append could work. Append could definitely work. I think that's what I want to do. Yeah, see that? That's definitely what I want to do. So we're gonna do a filled locks.append. We're gonna pass in this guy. Well, a mutable reference to that guy. And that should do it. Oops, don't want to return unit. That'd be a bad idea. Oh, right, but this is going to return unit. I forgot that yeah, the append operation definitely returns unit, so we're going to have to do this. There we go. What's this? What is it complaining about? Cannot borrow immutable local variable filled blocks as mutable. Oh, well, in that case. How about this? No? Okay. Got it. Wait, did I do it too early? Maybe I did. I'm not sure. Yeah, it seems like it's okay with this. Alright. I'll just leave it like this. And let me think. I do believe this is all we really need to do. Maybe add some like error handling here for the if let. We could also add some debugging asserts as well to make sure that progression filler is in has the right number of locations and items before it starts trying to fill things in. That would probably be a very good idea, because if I don't harden this method or function, whatever, I'm not going to be able to, well, I'm probably going to run into errors, basically. So yeah, I'm going to roll with this. So yeah, we have this fast filler here already. We're going to try ignoring that, because we're going to do a real fill locations now. Without thinking about it too hard, I think... Oh, I need to supply more items. That's right. Okay. How many locations do we have? Only 3. We need enough locations for every item, so we should definitely try to include more locations. Oops. Yeah, the nice thing about this enum is I'm going to be able to actually give names to my locations later. Oh, I keep making that typo. Don't do that. So this gives us, what, 5? No, 6? How does this give us 6? Oh, because I have 2 twice. Duh. I was like thinking, wait a minute, that doesn't really make any sense. That doesn't add. Yeah. Just keep doing this. And we have a non-exhaustive patterns problem here. So we're gonna have to fill those in. And I kind of want to actually implement some real logic here so that I have a proper test. Then I can refactor that test so that it's actually in its own unit test after this. Don't have to play with other things. Right, so I guess we have the items here. What I probably should do is pass in the borrowed items to like several functions, and each function will just each function should just handle a different case. So I'm gonna just find a function out here. Still not really sure if it's more or less idiomatic to have just these freestanding functions all over the place. But I'm doing it anyway, so. Let's put I don't know. What should I do here? I guess we could just say I'm actually not sure. Alright, we'll just have 3 items, I think. Maybe this is like the like a 50 rupee or 20 or a big 20. Pretend this guy is a big 20. It's gonna be a junk item. And the rest of these are progression items. Yeah, I think that makes sense. So I'm gonna do this kind of like a pretend thing. I obviously don't really intend on having like big 20s in the final game. I haven't really thought too much about how the final game's gonna come out, actually. I just mostly wanted to dive in and see if I can crank out the algorithm and get an actual kind of game working before I start worrying about like the design details. That could bite me in the butt though, actually. If I'm thinking about it, I probably shouldn't do that. I probably should actually plan some stuff out first before I dive too deeply into this. But let's see. So this is the progression items. And of course we use this sort of new type pattern thing to ensure that these are all progression items. I could add even like an assert that like does a filter and checks, oh, are these progression items? If they're not all progression items, then don't do this. No, don't run the progression filler. Yeah, let's just copy this and do junk items. So we have to have the same number of items as locations. That's pretty much something that always has to hold true, no matter what filler you're using or whatever. You always need to have the same number of items as locations. So that gives me an idea that I need to change filler.rs. Yeah, I need to make sure that we have the same number of items and locations. So locations.length is equal to prog items.length plus other items.length. There we go. That should do it. So yeah, we will have this debug assert to ensure that that holds. It's going to take C parameters, so we're going to give him junk items. There we go. You can have ownership of that even, I don't care. Alright, so 3 item 3s. And we're going to have 6 locations. And for our locations, let's say you need item 0 to get to location 0. How am I going to do that? with just these items. What is items? This is the is this the assumed accessible items? I should label this because I don't actually know right off the top of my head. Where was that? Where do I call this? Is accessible. Location is accessible with progression items. Oh, well, that's not super helpful. So progression items is the assumed accessible items, I believe. Yeah, so prog items has to be the list of assumed accessible items. So I'm gonna mark that down right here. Items is the list of assumed accessible items. Seems like a good comment to leave. Yeah, I guess we could just throw in some methods like has item 0. It takes labeled items. And what else does it take? Nothing. Right, we don't need anything else, I think. We just want to return a boolean. Bool. So if we want to see if it has that, we'll just do items dot... Is there a contains method? Actually, I'm not really sure. Yeah, I'm not sure. Let's go look that up. Rust vector, or I guess rust slice contains. Oops, no, I did not do that correctly. That contains is too restrictive. Well, maybe that's the reason why they don't have that. Alright. Oh. I think I want this. Slice primitive type. Oh jeez. This is kind of confusing. Okay, what's first do? That just gets the first element. Okay. Do they have any kind of like contains method at all, or is that just not a thing? I might have to convert it into an iterator. That might be what I have to do. Yeah, didn't really think about this. Huh. Starts with. It has a starts with. Oh, okay. Binary search. Binary search is the sorted slice for a given element. Oh, okay. Sure. Can I binary search this, though? That I wouldn't think I would be able to. It has to be a sorted slice, right, okay. So if it doesn't implement ORD, then you're not going to be able to do that. I thought that would be a little bit strange if I could. Can I sort this? I don't think that really makes sense, right? It's just items. I guess if I sort it by ID, maybe? Maybe. Yeah, I don't know. I haven't thought about that. Nothing here really strikes me as the kind of thing I need, other than maybe the binary search. Oh, I can do an into vec. Okay, that's... Okay, that might be what I need to do. Without clones or allocations, nice. To vec copies it. Alright. Fair enough. Is this what I want to do? Because vector has a contains method. I might actually need to do an into vec here. Yeah. Let's see what this is. Oh, this doesn't look very useful. Sure. This doesn't seem like what I'm looking for. Oh, okay, I see. Yeah, that's not what I'm looking for. I mean, I guess this might be what I need. Alright. Windows. Is there a Windows method or function on this? Maybe. Huh. Yeah, I'm not sure. Okay. Well, I think I have some options then, right? Number one would be to convert this into a vector, and that seems like it's pretty doable. I'm gonna have so many borrow checker issues. Doesn't matter, I guess. I'll just roll with it. Item. Ooh. Labeled item. Item. Oh, I don't know where this is going. I forgot how labeled item works. Right, labeled item wraps a thing. So I'd need to get the actual unlabeled item out first. Okay, that's not too bad, I think. Yeah, we can do... Oh, for item in items. So yeah, that gives us a labeled item. Then we can do a pattern match, I guess. No, this is no. What am I doing? I don't feel like that's the right thing to do. Is it? I get the labeled items and then I match. I do like a pattern match on them to get the inner item. Oh boy. And if it is equal to... okay, yeah. I think I can do something here. I could do a search. That's fine. Yeah, I don't have to do like contains necessarily. What I'm thinking right here is iter. I don't need to even collect this iterator. I can just do a map. Or I could do... Could I do a take while? Would take while work? I think take while could work. Yeah, let's look for something. Whoa, while sum? That's interesting. There's some interesting methods here. Yeah, I didn't know about like most of these. Oh, yes, take while, right down here. Take while ref. Ooh. Oh, interesting. I think I just want take while. That seems a little easier to work with. Alright, so take while. Or maybe I want to even do like a skip while? I don't know. Ultimately, I'm just trying to figure out if this collection, this item collection, contains a given item, right? Like, I should be able to just construct an item like the way I'm doing it here, and then check against it. So this really isn't as hard as I'm making it out to be. So we'll just check if item equals that. I think take while takes an argument, right? Or like the closure in the take while takes an argument. Where is iterator? Yeah, I don't need zip. I want to look at take while. I could even do like a filter. I'm not really sure which one is better or more performant, but wait, do they have any? Do they have the there's an any method, isn't there? Because there's one in C#. I'm pretty sure there's an equivalent to that in Rust. There must be an any in this language, right? There has to be. I know there is. All. There we go. Tests if every element of the iterator matches a predicate. Okay. Right, and it short circuits. And here's any. This is what I wanted. Any. Test if any element of the iterator matches a predicate. Perfect. That's exactly what I need. We'll just use a any. Yes. And it takes a... Okay. It takes... What? If any item is greater than 0, then it will... Right, return a boolean. Perfect. And I think these items, I should be able to, yeah, see the type is a reference to a labeled item, so I can just dereference it by doing that. Check if it's equivalent to this. And I think we need to do a little bit of this to make sure that it's in scope. Should be able to access this now. Yeah, there we go. Perfect. And now I can do a has item 0 here. In fact, you can do this for any item. Has item, whatever item. Which is, yeah, this could be type labeled item. And I could just put the item here instead. Well, I'd need to rename that item. Let's just call this assumed, or I don't know. Yeah, assumed item works. We'll just do that. I think that works. Yeah, I like that. That makes sense. Has item. Now we don't even have to be specific to item 0. We can just give it any item. But in this case, I do want to make it an item 0. So this will be a progression item, and it'll be item there. How do you do this again? My brain is melting. Just copy what main does. Item 0. There we go. Perfect. Yeah. This will be, maybe we'll have a few locations where stuff is always true, but so you need at least item 0 to get to location 0. There we go. There's the logic for that. Now we can also have like a has item 0 and has item, I don't know, 1. I could also do that. Let's make that a block. Yeah, it's a little bit easier to read if we have multiple lines here. Yeah, one of the downsides of the increased font size, it makes me think that stuff is drifting off to the right more than it might actually be. Can I get rid of this? Yeah, I can. Yeah, I kind of like the way that looks a little bit better. So if you have both items 0 and 1, then you can access this location. And the rest of them, maybe you can always access them. Yeah, later I might just refactor all this stuff out so it's not, so we don't have like these big ugly blocks in here for the logic. I might just have a separate method for each of these, or a separate function. That should do it though. So you have item 0, you're allowed to access location 0. If you have items 0 and 1, you're able to access location 1. And this is the assumption thing, based on assumptions. This doesn't exist. So this guy is going to return a bunch of filled locations. Filled locations equals fill locations. There we go. Perfect. Then we will be able to print those. That should be good. I'm sure there are some compilation errors. I don't write things perfectly on the first go usually. But, yeah. We'll just resolve them when we see them. Have I covered all my bases? I think I have, right? Yeah, the one place where I feel like there's going to be definite problems is in the filler. Oh, I can't compare. I don't have partial equality for labeled items. That's a good point. I do not. Oh, I can just do a partial EQ here. Shouldn't be. Yeah, that's fine. I'll do that. Oh, and I need it on item as well, of course. Can't compare the outer without knowing how to compare the inner. Oof. What? Oh, there we go. It did finish. Alright, let's, can we verify if this is working correctly, at least for this little small set? Let's do, I know, let's do this. We're just printing stuff just for testing purposes. We're not actually, I'm not actually expecting to do this kind of print line stuff later. Why do I keep doing that? Just use the tab. Oh, except the tab doesn't reach all the way over there. Fine, I'll just do this. So we have, what? We have, well, it is also passing my debug assertion, so I should remember that. We had, right, 5. Well, 6, technically. But if you're like counting 0 index, yeah. So we need to have 6 of these. Again, I could just copy and paste, but I don't want to. For some reason I decided to just type. There. It shouldn't have like an index out of bounds or anything. Alright, so let's look at this output. So remember, this is seeded. Filled location. I have progression item 0 in location 3. So as we saw here, where is it? Where is it? Where are my locations? Where did they go? Here they are. So location 3 is free, and you can put item 0 there. So the places that item 0 cannot appear are here and here, because you need item 0 to get to those. So that's good. We have item 1 in location 2. Okay. So item 1 is in this location, and that's perfectly fine. And item 2 in location 5. Yep. And then we have junk items. So junk items are in 0. There's a junk item in location 4. And junk item in location 1. And yeah, all of those, that all just makes sense. So yeah, there we go. I want to say that this is a working algorithm. I mean, there might be some bugs, but the algorithm itself is fairly simple. So yeah, I don't think there's too much room for error. Yeah, I don't think there's very much room for error here. And what's kind of nice about it is it's just pure on the outside. So this function right here just takes some vectors and returns a vector. So I'm quite happy with this I guess API. Let me check how long I've been recording. Not that long. So we have some time. We can start writing some unit tests. And it's been a while since I've written unit tests in Rust, so I do roughly know how it works. I just don't exactly remember all the finer details. But yeah, we're gonna start writing some tests. So let's go look up how to write tests in Rust. Let's see. Hopefully they haven't changed too much in the second edition. When I first picked up Rust, I only read the first edition of the book, which had a lot less in it. There's like way more sections in the book now than when I read the first edition. So yeah, it's a lot of stuff here that I probably should cover. But I figure I know like enough of the things that are already in here that I don't have to read every section, so it's just a matter of trying to figure out which sections should I read and which ones shouldn't I read. Or shouldn't bother reading, I guess. Tests are okay. Yeah, what is, I guess, kind of nice but somewhat controversial about Rust is that it allows you to do white box testing. So typically, you won't be able to test non-public functions. I believe that Rust lets you test like non-public functions, so I'm kind of considering just, you know, having the extra tests for the 2 fillers. I mean, the fillers, like these 2 fillers should be public anyway, right? The fast filler and the progression filler, I mean, they're general enough that I feel like they could be public and it wouldn't really make a difference. Although I am only using it here. Yeah, I am only using it here. Maybe I shouldn't. I shouldn't try and make things public too early. Seems like a bad idea. Yeah. So let's see, we need to do something like this. So did they, let me just quickly read through some of this to make sure that it's still the same. Because usually you put the tests, or at least in the first edition, they put the tests in the same file as the stuff that you're testing. I'm not sure if that's still like idiomatic. Oh boy. Test attribute, blah 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 blah. Library project with cargo. Tests work experimenting with the template test generated for us. Okay. Adder. Adders are snakes, I think. The contents of the source lib.rs file in your adder library should look like this. Where does it say, like, where these tests should go? I imagine it hasn't changed between then and now, but not 100% certain. Right, us can compile code that appears in API documentation, but I'm not doing documentation. No, at least not like that. Because I'm not really writing a library. Yeah, okay. Right, and we want to use assert to check that the results are what we want them to be. Makes sense? Yeah, okay. I got some failure messages, yeah. Checking for panics. Huh. Okay, well, I have no idea. I'm gonna just follow the old way of doing things. Because hopefully it hasn't changed. Yeah, and I should just use super. Filler test. Okay, so one thing I do also need to remember is that this is a hard-coded RNG. That needs to be moved. So the RNG has to be passed in. Let's just do this. Oh wait, no. What am I doing? This is just a function signature. I don't need to do that. Yeah, so if I pass in the RNG and then just call rng.shuffle as we would, we should be okay. So you need to put the RNG right here. Oops. Oh, fast fill is private? Oh, right, I don't need it. Standard RNG is unresolved. Probably because I need to fetch it from here. Yeah, do that. Put that right here. Perfect. Give it the RNG. There we go. Seems good to me. This is a little bit long, actually. So what's kind of nice is they have this like little gray line here that tells you where character number 101 is positioned. I don't know why 101 and not 100, especially considering that these characters are like they're one indexed, but whatever. What I could do is move that to another line, move this to another line. Also, I guess these tags are sort of part of the problem. These little IntelliJ generated tags. So, yeah, that seems fine. We'll leave it like this. Shouldn't change anything either because the seed is still just 0. So with that, what do you mean unused import? Yeah, this is exactly the same. Yeah, let me just check on this. Okay, if it's not being used, we don't want it. If this is not being used, we don't want it. Use import suitable RNG. Oh, I don't need this either. Cool. Good. Very good. So filler test. Let's start filling in the filler test. And essentially all we need to do for the filler test is do what we have here in main, because main is going to tell us exactly what we want. Oh, I guess I do, well, I don't actually have to use it there, though. I can use, what? Oh dear. Super item. See, that works. I'm not really sure I wanted to do that, actually. Never mind. If I include item in here again, I don't think that's going to hurt too much. Yeah, just because I know that only the tests are going to be using it, but still, I'd feel more comfortable just having it there. Anyway. I mean, what could that possibly do? I think I meant to say what harm could that possibly do, but I think it's pretty obvious what I meant. So, filled locations. It's going to be this, and we know what filled locations should look like. It's going to look like this. So all we have to do is assert. Assert a bunch of things. Assert equality. Oh, can I compare filled locations? I don't know if I can. Nope. Let's implement partial equality for these guys then. Can locations be compared? Yes. Locations can be compared. Filled locations can be compared. We're good. Wait, no, I need a filled location. Yeah, and all I have to do is fill in these tuple structs as follows. I think location is just that, right? Yeah. There we go. We'll just do this a few more times for the other locations, and we're good to go. show. Just put semicolons all the way down. I mean, that should be okay, right? Right, so this is item 1. It's location 2. I'm probably going to want to update these tests later when I decide what the actual item names and stuff are going to be, but for now, this is fine, I think. Nothing wrong with doing it this way. So yeah, we know what this looks like for this seed. I don't know if I actually want to do testing on like the seed level, like testing exact results given a certain seed, because I mean obviously that's pretty prone to being changed, but I guess for now it's okay. Yeah, because there might be some changes I need to make to the logic, but I think that this at least somewhat captures. Well, what I could do is make sure that there is no item in that certain items do not ever appear in certain locations. That's another way I could do the test. That might actually be better. I think that'll be another test that I do. I'll write a second test, and I'll do it in that way. But anyhow, we want to get item 1 in location 2, right? We did that. Item 2 in location 5. And then a bunch of item 3s, and all the item 3s are going to end up locations 0, 4, and 1. There we go. If we run the test, it should pass. Since it's literally just doing... Oh! Unexpected end of macro invocation? Did I do something wrong? I may have done something wrong. Wait, how do you use assert equals? I mean, this seems like the right thing to do. Oh, it's it takes two arguments, doesn't it? Right? Assert equals. Yeah, it takes two arguments. I'm being silly, of course. I don't have to do this equality check. I'm already doing an assert equals. Which one is expected and which one is the input value? I didn't check. I like to think of it as like a left should be right, you know, like in behavior-driven development language. But yeah, since Rust doesn't seem to have that kind of syntax, I'm just going to make the assumption that that's correct. How much time do I have left? Oh, not too much. Oh! We have a problem. We need the seedable RNG. Yeah, so we do need certain imports, specifically just for... What are you complaining about? It's right there. Yeah. That seems better. Test failed? What? Oh, it panicked. Oh, that's not good. Oh, because the assertion failed. Oh, I said that was a progression M. These are not progression M. See? Perfect. It's exactly the kind of thing that I... Well, I don't know if this is a good case. This might not be the best example. But yeah, I labeled item 3 as a progression item when I shouldn't have because of copy and paste, and that was wrong. Don't do that. This is kind of why I want to make sure that I have these labeled items. Why does it say this is unused, though? I'm using it. I'm using it down here, but... I don't really want this warning, so I think I'm actually gonna put that down here. Yeah. Alright, maybe I should just import stuff that I need for the tests down here. Right? Like, doesn't that just make sense that I would do that? I don't need it otherwise. It just kind of makes no sense to do things this way. Oh. Item 3 ended up in... Huh. Yeah, this is exactly the reason why I don't think that this is the right way to do these tests. Okay, no, this definitely is not the way to do these tests. How am I gonna make sure that this all works correctly? I guess I could check the number of filled locations. Right? Black box testing. Yeah, let's just do it that way. Check the number of filled locations. Alright, oops, whoa. Double clicked shift there. That reminds me, I should try and learn, or relearn, the shortcuts for IntelliJ. It's been a while since I've used IntelliJ, and I was fairly proficient with it at one point. Then I got sucked into Visual Studio land, where all the key bindings are completely different. Now I'm just kind of, yeah, gathering my bearings again, I guess. Oh yes, we just need to do that. Yeah, so we'll assert that the length is 6, and we'll assert that... Right, item wasn't actually being used in the actual source up here, so I can actually do like a super. No, what I want to say is do this. Yeah, there we go. If I do that, that test will be fine. Wait, what time? Okay, we have 3 minutes. We'll have just enough time, I think. So check that this is length 6. And assert that we want to assert that this thing doesn't contain that. Right. How do I check that something doesn't contain? I guess I could use... I could convert it to an iterator and do like a dot all or dot any. And I can even take ownership of this thing, I think. No, if I take ownership, then I'm gonna wait. Yes, I'll lose access to it, so no, I don't want to do that. I do want to just have an into, or not into it, I just want an iter. Pretty sure I just want an iterator. And instead of assert equal, I can just do like assert true, or assert. Can I do like assert false? I guess I could just negate the entire thing though. Filled lock. Oh yeah, this is getting kind of messy. Yeah, this line is too long. It's getting annoying. So I want to make sure what do I want to make sure? That the filled locations progression item is not a certain thing. So I could just do like filled lock equals this. Yeah, that works. Yep, pretty sure that's what I want to do. Why is it complaining? Oh, not enough parentheses. If item 0 is in location 0, we have a problem. Right? Yeah, if item 0 is in location 0, we have a problem. If item 1 or item 0 are in location 1, we have a problem. Right? Because you can't get to location 1 unless you have both item 0 and 1. So that means neither of those items can appear back there. That would make sense. Let's do that. Oh yeah, I need to also drop the reference. I don't want that reference there. I have to say, these little helpful hint things that tell me the types, they're really nice. I like them. They're incredibly helpful. They're a little bit verbose, though. They're stretching my code out all over the damn place. That's a little bit much. Kind of prefer. I don't know. I don't know what a good solution would be. Maybe if you could hover over it to see the type, instead of having all these things kind of like inlined like this. I wonder if there's a way to change that setting. But yeah, this will check that filled locations does not contain item 0 in location 1. I realize this is inefficient because we're iterating over the collection multiple times instead of just doing one pass over it. But A, this is a test, and B, I can refactor. It's fine. Doesn't matter. There we go. So as long as these conditions are met, we should be okay. Let's run it. Oh, we went over a little bit. Oh well. You don't move out of borrowed content. What do you mean? Prevent move use ref filled location. Are you sure? Do that again. Oh, and I can't compare. Oh, because, right, those are going to be references. I didn't think about that. Okay, hang on. Instead of doing it that way, what I should have done was just add a reference here and here and here. That should fix that. Should be fine. One test passed. Yay! Perfect. Excellent. And we could even not have this be seeded, or like we could even you know, I guess like fuzz test this, because as long as it doesn't put the items in those certain locations, we're happy. We're good. So yeah, that's basically how to write some tests for the little algorithm that we wrote. I'll probably be improving this as I go along, but for now that'll do it.